Hello everyone. This is video. I'm going to demonstrate example from textbook, and it's about the calculation of power. Okay, it's a biking problem on the inclined surface. Okay, here we have a person doing biking on inclined surface, and the surface is in the inclined angle is 5 degree. That's quite small. 5 degree for the car which we use. Okay, let's use this. 5 degree. Sorry, it's 5 degree. And it's doing biking on surface, and you want to do a steady velocity, keep the steady velocity. Okay, that's the key. Keep the steady velocity. And the magnitude velocity is 4.4 meter per second. Okay. So, so and give information. Okay, and the information is and then the people, the person is 66 kilogram, and the bike is 9 kilogram. Okay, and what else? Okay, so and you say like the air resist. Okay, let's do the abbreviation. Air resistance is 8.2 Newton. And this set out a problem. He say if this man biking on the surface, he want to do the steady velocity motion and velocity 4.4 meter per second, and at the same time the air resistance 8.2 Newton. So what's power? What's power does the man has to do? What's the power? The power does the man the person has to do. Person has to do. Mm-hmm. Has to do. Okay, this is the first one. Okay, this is the first problem. Okay, so when the people do the biking, the person do the biking on the surface and goes up. Okay, so let's take a look at this. The air resistance 8.2 Newton. It must be opposite to the direction of motion. Okay, that's why it's called resistance. Okay, its direction must be just opposite to the moving direction. So when the direction of resistance is looks like this. Okay, it's 8.2 Newton. Okay, and it says you want to do the constant velocity motion. That means you have to produce the force to balance the air resistance force, right? So let's say if air resistance is negative, yeah, if this moving this direction is negative, so you need to produce a positive force to overcome this resistance. Okay, so that means you need to so you how to say you produce the force. How to say generate? How to do the force? The force you need to produce. What's the name? Force. Okay, that's main plus bike. Okay, the force you have to generate to overcome the air resistance. So there's a negative of air resistance. Okay, so you must overcome air resistance. That's why it's a negative sign. So the F, the force produced by the man and the bike, so it's equal to minus 8.2. Okay, Newton. So it will become 8.2 Newton. So let's calculate the power. Power is equal to, yeah, last video I say force times the velocity. Force times velocity. So the force, this is the force we reproduce, right? So it's the same direction. So it's 8.2 times the velocity is here. Velocity is 4.4. Okay, so let's see. 8.2 times 4.4. Yeah, where's my calculator? 8.2 times 4.4 is 36.08. 36.08. And what's the unit of power? Don't forget about it. It's a watts. But this is not correct answer. Okay, so it's not correct answer. Why? Okay, yeah, you should think about why this is not correct answer. Okay, because right now we only consider air resistance. Okay, but actually in this problem, there is another resistance. There is another resistance. Yeah, you can think about it. Okay, but since we are recording, so I don't have time to allow you to think. There is another resistance. Okay, we draw the force diagram of this system. So it's 5. Okay, let's say we treat the man and bike as a 1 point. Okay, and this is a normal force. Okay, everything on the surface always a normal force. And also here is the weight. Weight is mass bike plus mass man. Okay, G. Okay, so it's total. So it's total 66 for man. Okay, so it totally is 75 times 9.8. Okay, well we'll calculate later. So when you're climbing up the surface, doing a biking on the inclined surface, there is another resistance. There is another resistance. Which kind of resistance? Yeah, you have resistance comes from your weight here. Okay, here is your weight. Okay, and your weight, yeah, is a force and it's a vector, and then he has component just opposite to your moving direction. So we decompose this vector. Okay, here and here. We decompose this vector. Decompose this vector. Yeah, you see, we can decompose this vector by these two. Okay, by these two vectors. Okay, so this weight, this vector has a component that which is opposite to your moving direction. So this also causes resistance. So we also have to consider this resistance. Okay, so what's the force for this component? Yeah, do a geometry. You're very careful. So here is 5 degree. So maybe this 5 degree here, 5 degree here. So what is this component? This component is is mb plus mm g times cosine or sine. Be careful. It's sine or cosine. Very careful. It's sine. It's sine 5 degree. Okay, so this force, what should we call its name? It's called, yeah, no, I really cannot come up with name. What should we call this? F what? F what? F what? It's the resistance from the mass. Okay, let's call it resistance 1. Okay, let's call it resistance 1. It's called FR1. Okay, FR1. Okay, so we have to overcome the resistance from your weight. Okay, resistance from your weight. So also you want to keep the constant velocity of motion. Your power, your produce power, your produce mass power also has to the same amount of this resistance force. So right now, if we consider the both air resistance, so the correct force is okay. Let's write it here. Now we have to add the other plus minus F is called resistance 1. Okay, resistance 1. Okay, because I will ask another problem. Maybe there is another resistance 2. Okay, So let's rewrite this equation. So it will become like this. Okay, it's minus 8.2 Newton and plus the minus resistance for resistance force 1. Okay, so it's 75 kilogram. It's 66 plus 9, so times 9.8 times sine 5 degree. And its direction is this direction, and we also said this direction is negative. Yeah, this direction is negative, as we say. This direction is negative. So it's negative what? Okay, let's do a calculation. 75 times 9.8 times sine 5. So it's 64.06. Okay, let's say 64.06. Okay, okay, because and then we have minus sign in front of this term. Yeah, because we want to produce the force. So the force you produce, its direction is reverse to your resistance. Okay, so it's 8.2 plus 64.6. So it's value plus 64.06 plus 8.2. So 72.26. Okay, so what's the power? So what's the power? So F times V, and here you should change the force. Okay, the force is 72.26 times 4.4. So what's the result? 72.26 times 4.4, and so yes, roughly 318 watts. Okay, that's the correct answer. Okay, so when you're biking on a surface, so you have two resistance. One is air resistance. The other the other resistance is comes from your weight. Okay, so you have to consider the both. And add another condition is the surface, the friction coefficient. As another question, if the kinetic friction coefficient is, let's say, 0.8, so what's the power you need to keep the constant velocity motion at 4.4 meter per second? We add another criteria. Not criteria, add another condition. Is there's a friction between your tire and surface, and kinetic coefficient is 0.8? What's the power you need? Intuitively, you need more power. Yeah, yeah. Now you have to friction to overcome, so you need more power. Okay, so what's the amount? So let's say, okay, so right now we've completed friction, so you have another friction. Let's call FR2. FR2. You have another friction called FR2. Okay, FR2. The yellow is F. You cannot see it. There's another friction called FR2, and this comes from the friction between your tire and surface. Okay, and friction, we in previous chapter we learned that friction is proportional to your normal force, and the ratio is kinetic friction coefficient, because right now the bike is moving, so it's kinetic friction is a kinetic friction coefficient. And so okay, we set this value 0.8. So if we know the normal force, we can find out the friction force. Okay, we find the friction. So what's a normal force? Yeah, what's a normal force? Okay, and we assume there is no acceleration, no ACC in this direction. Okay, because if we assume this bike is only doing the motion in this direction, and there is no acceleration in this direction, and this direction is perpendicular, it's perpendicular to its moving direction. We assume there is no acceleration is in this direction. So at this criteria, we can compute the normal force. Okay, because there is no acceleration in this direction. So for Newton's second law, we can have the n. So if this is positive, this is a negative. The normal force. Okay, so there's a component from the weight, mg cosine 5 degree, mg cosine 5 degree, mg cosine 5 degree. Okay, and this direction is negative because we define this direction is negative and this direction is positive. Mg minus mg cosine 5 degree. And there's no acceleration in this direction, right? So m times a, and a is 0. So your normal force is mg cosine 5 degree. And and m is the mass, and mass from the total mass from the man and the bike is 75, and times 9.8 and times cosine 5 degrees. So what's the value of this? So the friction force is 75 times 9.8 times cosine 5. Okay, so the value is 732.2. 732.2, 32.2. That's your normal. That's your friction force. Okay, so let's go back to this equation. So the force we want to produce from the man and the bike, you have to overcome air resistance and the weight, the component from the weight, some component from the weight. Oh, and also we have to add one more, yeah, the friction. Okay, we call it force resistance 2. Okay, this resistance 2 comes from the friction force. Sorry. This this is not friction force. This is just normal force. So Fk is equal to 0.8 times, which is 585 585.8. Okay, so this is just normal force. Okay, the friction force is normal force times the friction coefficient. Okay, so this equation will become like this. Okay, we add one more term, and the friction force, its direction is also this way, and we want to overcome, so it's a negative. We put a negative in front of this force. Now, and it's minus 5a 5.8. Okay, so what's the value of this? And then finally we have three terms add together. 8.2, 64.06 plus 585.8. So what's the total? What's the final? 8.2 plus 64.06 plus 585.8. So totally is I think is 658.6 and units in Newton. And so what's the power we have to generate? It's like the force times velocity. Okay, so we finally get the force. The force is, we are almost to finish, 658.06 times 6.4. So it will become 2895.5 watts. Okay, so if you are to overcome the air resistance, overcome your weight, overcome the friction, you have to produce 2,895.5 watts to overcome this resistance and also keep a constant velocity motion. Okay, I hope you can understand this problem too. We spend a lot of time. Okay, so I just stop the video here. So hope you can understand this problem. We'll see you in the next video. Bye bye. Whoa. Whoa.